were constantly having the problem of forgetting our keys and getting locked out of our dorm. So we invented a lock that doesn't need keys, only your phone and your imagination.
If your phone's dead, there's a backup button system so you can unlock your door. Enter the preset code and you'll never be locked out of your home again.
Have you ever forgotten your keys? If the answer is yes, then we have the perfect product for you. Now you can open your home door with just your Bluetooth-enabled smartphone and the touch of a button.
Now you're probably wondering what happens if your phone's dead or if you forgot your phone. For this reason, we programmed a button sequence to unlock your door.
Now you're probably wondering, how does this all work? We use the NRF 8001 breakout to establish an easy-to-use wireless link between the Arduino and any Bluetooth-enabled smartphone. It works by simulating a universal asynchronous receiver-transmitter device and can be used to send ASCII data between an Arduino and the Bluetooth device of your choosing. The other technological element used in the Bluefruit portion of this product is the Adafruit Bluefruit Low Energy app that can be found on the Apple App Store. Similar apps are also available for Android devices now that Android supports Bluetooth Low Energy as well. Having one of these apps is necessary to connect and interact with your Arduino attached to the lock. This all is what is truly special about the technology used in this product. Because the NRF 8001 uses Bluetooth Low Energy instead of classic Bluetooth, it can be easily manipulated from both iOS and Android 4.3 or higher devices. This ease does not exist with classic Bluetooth because it has many big contrasts that make it difficult to work with. In our product, we integrated these technologies by using the phone app to send the unlock code in the form of ASCII data to the NRF 8001, which is connected to the Arduino Uno with the lock. The coding on the Uno checks if the right ASCII value was sent and then moves the lock accordingly. Note that an Arduino Uno had to be used because a Leonardo does not have Bluetooth compatibility.
We incorporated an accelerometer into our design by using it to detect when the door has been locked or unlocked. The accelerometer is attached on the Arduino Leonardo, which is mounted on the door lock component, and therefore connects the X and Y position values to determine when the motor has been moved. We set the threshold value of the accelerometer to a specific value that measures when the servo motor has turned 90 degrees, and subsequently tells the LED to flash for 1 second when the threshold has been met. This way, the user always knows when the lock has worked. In addition, the aLock has a switch that turns it off and on. The lock off and on. The accelerometer, LED, and switch are attached to the Arduino Leonardo, which is mounted on the servo motor. The push-button system allows the user to unlock their door without the use of Bluetooth. This backup system is similar to the idea of a hidden spare key. Each button is connected to its own digital pin on the Arduino Uno. The code uses a flag variable system to detect the sequence in which the buttons are pressed. If the buttons pressed match the predetermined code, then the motor will be told to unlock. If you mispress a button in the sequence, you can simply restart your sequence again to unlock the door. We program the servo motor to move by writing the motor to move counterclockwise for a certain amount of time until it had completed a 90-degree turn. We did this through a delay function for how long the motor turns, and found this value by simple trial and error process. The servo motor, along with the push-button system and Bluetooth chip, are all attached onto the Arduino Uno.